Hello. Hello, Kasim. So, we were just talking about if you thought the questions were easy, medium, or hard. So, should we like boost the difficulty, or should we like make it stay the same? Or do you have any other thoughts?
Maybe stay the same.
Okay. All right. What about you, Elvin?
I was away. Are we talking about the homework?
Yeah, we're talking about the homework. So, do you think the homework is hard, easy, or medium?
I think the 10 to 18 page is pretty easy,
Yeah.
but the next page, I'm not very sure.
Okay. All right. So that means do you guys want to switch, for example, like the first page for some harder problems, or do you think we're fine just doing the 2 pages? Hello, Franklin. Can you turn on your mic? And I'm going to ask you a question. So do you think the problems are easy, or are they hard, or are they medium? Franklin, can you hear me? Franklin, did you turn on your mic? Everybody else can hear me fine, right?
Yeah.
Yeah.
Okay, good. It's just Franklin then. Franklin, can you hear me? Okay, I'll take that as a no. That means I'm going to type in the chat. 1 sec. Never mind, I can't type. Alright. So, Franklin can't hear us. That's bad. But so now going on to my next question for you guys. I want you guys to all think of the problems you found interesting or you thought it was challenging, and then tell me these questions, and you also tell me at least one question that you're going to explain. Hello, Franklin. I saw you. Can you hear me?
Yeah.
Okay, good. All right. So I was just asking whether you thought the questions were easy, hard, or medium.
Like overall, or like, are we choosing the specific questions?
Well, whatever you want. If you have something. Oh, continue.
Wait, so are we what are we talking about?
Oh, we're talking about if you thought the questions were easy, hard, or medium.
For the most part, pretty easy.
Okay. All right. So let me just write them down. All right. So now I was just saying that you should right now we want to think about right now you should think about like what questions you felt were interesting or you thought were challenging, and what questions, which means more than one or one question, are you going to explain?
Okay. So
Okay, you can think. I'll give you time to think. All right, first off, we have Nathan. Nathan, what questions are you going to explain?
Mm,
Oh, you want more time to think?
I'll do 13.
13, okay. And what questions did you find interesting or challenging?
I couldn't do number 22.
Number 22, okay. Is there any other ones?
25.
25, okay. Okay, and all right, is that all?
Yeah.
Okay, all right. Next up we have Elvin. So Elvin, what question or questions are you going to explain?
I'll explain 11, I guess.
Okay. And
Um, so it says Lily is 90
wait,
centimeters.
not yet.
Oh.
Wait 1 sec. Okay, we need to get everybody through first. All right. And what questions do you find challenging or interesting?
The question 17.
Yeah. And
I found it challenging and is interesting because you have to go like you have to reverse math sort of.
okay. And any other questions?
No.
All right. Okay, so next one we have Kexin. Kassim. What question or questions do you want to explain?
Question 14.
Okay. And what questions did you find interesting or challenging?
Question 16 and question 24.
All right. And now Franklin. Franklin, what question or questions do you want to explain?
22.
Okay. And what question?
25.
Wait, what? Did you say you want to explain 25 or do you find it challenging or interesting?
I can explain that.
Oh, you explained 25. Okay. And what questions do you find challenging or interesting?
I find 24 interesting.
Yeah.
And 17.
Okay. All right. So now let's start. So, okay, Alvin, you can start. Wait, 1 sec. 1 sec. Oh, wait, never mind. Wait 1 second. All right. Now I'm sharing screen. Alvin, if you want to write on the board I'm using, like this whiteboard thing, then all you have to do is go to the share screen settings. Like,
yeah, I know.
know how to do it? Okay.
It's the annotate, right?
Yeah.
Okay. So Lily, no, can't. No.
I can do it if you want.
Okay.
All right.
Delete
You just tell me what to do.
So could you write an L?
Okay.
An A?
Wait 1 sec. Okay. L, and then we have A and S.
Yeah. So it says Lily's 90 centimeters tall, and since free thirds is 90 centimeters in this, the extra third is 30.
Yeah.
And set def is, what is it? Since 120 divided by 4 equals 30, that extra quarter would be 30, so it would be 150 centimeters.
Okay. All right, good. The next one we have Number 13. Nathan. And you can draw on this too.
Okay.
Or do you want me to draw?
I can draw.
Okay, you draw then.
After you draw, I'm bad at drawing.
Yeah,
So-
you want...
So we need like 3 slots. One. I'll just do it.
Okay.
So we have one. For the first possibility, we have 2 out choices. And then for the second, we have 3 sport choices. And then for the third, we have 4 music choices. We multiply these together. Well, yeah. And then we get 24.
Okay. Good. All right. Next question. We have number 14. Cassie, can you explain number 14?
Yeah.
Okay.
So Team Canada won 17 out of 100 medals. So you put that as a fraction. And then it says which one of the following is closest to the fraction of medals that they won. So I first divided 17 by 100.
Okay, 1 sec. All right, 17 by 100. Yeah.
Which is 0.17.
Yeah, 0.17.
And then I looked at the answers. So A is not right because 1 divided by 4 is 0.25. So that's not right. And then I looked at the second one, which is 1 divided by 5, which gives 0.2, which isn't right either. And then I looked at the third one, which is 1 divided by 6, and that gives 0.16, and that's the closest one that I could find. Because if you divide 1 by 7, it gives 0.14.
Yeah, okay. So, and we know that as the denominator gets larger, the number gets smaller. And 0.16666, like repeated on and on, is smaller than 0.17. All right, great. Okay, so now we have question 16. Question 16. Does anybody want to explain question 16? Okay, I'll explain question 16. When the radius of a circle is tripled, how are the area and circumference of the circle affected? We have the radius. Okay, whatever. We have the radius, and the radius is tripled, so radius times 3. So what is the perimeter of a circle? The perimeter of a circle equals 2 times radius times pi, which means the perimeter, since now the radius is 3 times what it used to be, so now it's 2 times 3, which is 6, r pi, which means that the perimeter tripled, and the area equals r squared pi, which means that after we triple r, we get 9r squared pi. So like this is the original radius. And so this is 9 times what it used to be. So times 9. And you look at the answers, and the area is 9 times as large, and the circumference is 3 times as large. And that's true. So the answer is A. All right. Do we have any questions? No? Okay. All right, question 17. In Math Idol, there was a total of 5,219,000 votes cast for 4 potential idols. The winner received 22,000 more votes than the second place contestant, 30,000 more than the third place contestant, and 73,000 more than the fourth place contestant. How many votes did the winner receive? Alright, so first off, let's just make an expression. So let's say the winner has W votes, which means we have W plus W minus 22,000. So this is second place, plus W minus 30,000. This is third place, and W minus 73,000. This is fourth place, equals. How much does it equal? It equals 5,219,000. Alright, so we can simplify this problem by a lot if we just cross out 3 zeros on everything. And remember, the W's have to be they have to be divided by 1,000, because that's how much 3 zeros is worth. 1,000, 1,000, 1,000. We're just basically dividing 1,000 on each side. This way the number won't be too big and it won't take up too much space. Okay, so now if we simplify it, we add the W's together. So we have 4W divided by 1,000. And so we have all these subtractions, but we can move all these subtractions onto the other side, which means we add 22, add 30, and add 73, which equals 5,219 plus 22 plus 30 plus 73. All right, so now if we add them together, let me just erase it. All right, so now we have 4 times W over 1,000. We'll do the 1,000 later. And then over here we have 5,219 plus 22 plus 30 plus 73. So let's say we add 30 and 73 together, we get 103. And we add these two together, we get 125. And if we add these two together, we get, so 5 plus 9 is 14. And 2 plus 1, 20 plus 10 is 30. And plus another 10 is 40. And 100 plus 200 is 300. And then we have the 5,000. So we have 4 times W divided by 1,000 equals 5,344. And let's divide 4 on each side. Divided by 4, this is 1. And we have 13, so 3 times 4 is 12, remainder 1. 14, 3 times 4 is 12, remainder 2, 24. 4 times 6 is 24. So we have W divided by 1,000 equals 1,336. And if we multiply 1,000 on each side, we get that the winner has a total of 1,336,000 votes. And the answer to that question is D. So do you guys get it?
Yeah.
Okay.
Yeah.
Great. So we have 17 done, 16 done, and next one, 22. All right, 22, Franklin, could you explain? Franklin?
Oh yeah, sorry.
Okay, that's fine. Number 22, question 22.
How do I draw on the white thing?
Do you want me to draw? You can explain. You just say a bunch of words and I'll draw it down. Okay.
Okay. So can you draw the rectangle thingy?
Yep.
The shed.
Yeah, shed. And then we have the line. This is 3. All right. Explain.
So basically, you want to look at it like a circle, I guess. So Chuck, he can't go inside the shed, and he can't go through the shed. So then, if he walks in a full circle as far as he can go, then at the end of that, at the end of, can you like label the sides A, B, C, D?
Oh, okay. I'll label the rectangle then. Just one sec. All right. So A, B, C, D. Let's just say this, okay?
Okay, so we know that he can go to A pretty easily, and he can also go to B, and he can also go to C. But when he hits C, then the rope will get stuck there. So then he'll only have one.
So basically the rope, it goes to C, this is 2, and then we can curve around, and this is 1 more, right?
Yeah, and then we have quarter of a circle with a radius of 1, and then we have 3/4 of the circle with a radius 3, and then basically 3 times pi, pi r. So 9 times 5 subtracted by 1 times 5. So 1 times pi. Oh, I said 5.
Yeah, and then did you forget a step?
Yeah, I know. And then we have to get rid of 1/4 of 9 and 1/4 of 1.
Okay, so which means we have 3/4, and this is only 1/4. Right, continue.
And then when you do the math and add it together, it equals the 7 pi.
Yeah, great. Okay. So does everybody understand this question? Do you guys have any questions?
No.
Okay. Yeah, so you just have to look at it like a circle, right? Okay, next one, we have question 24. Yeah, question 24. Does anybody want to explain question 24? Okay, I'll explain. A lattice point is a point xy with x and y both integers. For example, 2, 3 is a lattice point, but 4, 1/3 is not. In the diagram, this is a diagram. How many lattice points lie on the perimeter of the triangle? So we have 2, 1. And then we have 17, 6. And then we have 12, 21. All right, so it's asking for lattice points, so whole number points. So first off, we need to look for whole number points on the perimeter of the triangle. So how we get from one corner to another lattice point is that we have to add some amount on the x-axis and add some amount on the y-axis to get to a lattice point. All right, so let's say, for example, we have 2, 1 to 17, 6. So right here, we can have, for example, we move on the x-axis 3 tiles, and then we go up the y-axis 1 tile, and then we get to a new lattice point. This is 5, 2. But how do we know that that the point exists on the triangle? Why isn't it like we go on the x-axis 2 and then we go on the y-axis 1? How come there's a point right there? Well, we can solve this question by drawing a larger triangle. So for example, we stretch On the x-axis, we go 15. On the y-axis, we go 5. So if we divide, since like this is a large triangle and there are similar triangles, so let's say we divide by 5, then we get a smaller triangle that is 1 and 3. So there are going to be a lot of similar triangles on this side. Yes. So now if we know that, we can just draw lines around the triangle. And we could see that this triangle's dimension is 10 up. Wait, no, that's not 10 up. This is 20 up and 10 across. Right here we have 12 to 17. So 5 across and 15 down. And right here we have 5 and 15. So what we need to do is we need to find the greatest common factor of the side length to figure out what similar triangles have like integer lengths, which means that since we have a lattice point, we have to add integer lengths to get to another lattice point, which means the small triangles have to be integers, which means they move across as an integer number and they move up as an integer number. So this all sounds confusing at first, but you'll see what I mean. So we have the greatest common factor of 15 and 5 is 5. So we can divide 15 and 5 by 5, so we get a 3 by 1. So we have 3 by 1s. We can just like draw out this entire triangle with smaller 3 by 1s. So then you will see that it becomes sort of like a staircase. And this staircase, every time you go to the end of a staircase, is a new lattice point. This is what we could do. And can we break down the up 1 and across 3? Well, no, because if we turn it into a smaller version, then that means the 1 is going to be a decimal number. So what I'm saying is, for example, if we cut this thing in half again, the height and the width, then we have 0.5 and 1.5. So since we have 0.5 and 1.5, if we go up by 0.5, we get, and we go across by 1.5, we get 3.5 and 1.5. This is not a lattice point. So that's why we have to find the greatest common factor. All right, anyways, that's enough talk. So let's just solve this. The greatest common factor for 15 and 5 is 5. So like we have the 3 and the 1s. And now we have to figure out how many of these 3-1 triangle, like how many of these lattice points are there. So we see that for each 3-1 triangle that is like on the edge of the big triangle's perimeter, we see that it can correspond to 1 point. And if we continue the pattern, let's just say like it's the point they correspond to is the point that has the angle that is of the smallest measure, which means it's like the sharpest angle. So we have 1 point, 2 point, blah blah blah, and then to the last triangle, we have one of it on its sharpest angle, but there's no point like right here. But that's okay. Let's first leave it blank. Leave this point blank. All right. So now we have 5, like we go up 5, and for each little triangle we go up 1, which means that there will be 5 triangles. So the 5 triangles on the edge of the big triangle, which means that there are going to be 5 lattice points on this side of the triangle, excluding one of the corners. So we have 5 plus, and we can do the same thing with this 5 and 15. it's the same thing, same concept. We add another 5. And as you can see, for example, if we have we count the lattice points and exclude this corner, it means that we've got another lattice point. We got back the lattice point at the corner we didn't calculate. So what about this side? We have 10 and 20. The greatest common factor of 10 and 20 is 2, which means that we divide it by, the greatest common factor between 10 and 20 is 10, which means if we divide each side by 10, we get 1 and 2. So we have these small 1, 2 triangles, and 10 of these 1, 2 triangles make up this large triangle. Well, that's on the perimeter. So that means we have another 10 lattice points. And note that, like, if we exclude one of the corners, then we will get all the lattice points on the triangle. So that means if we add 5, 5, and 10 together, we get 20 lattice points. So that was a little wordy. Do you guys have any questions?
No.
Okay. All right. Question 25. Franklin, if you would like to explain again.
Oh, okay. Can you like draw the triangle?
Okay.
Oh, and it's not triangle, the rectangle. Sorry.
Yeah. All right, you can start explaining now. Franklin? Franklin, can you hear me?
Yeah, sorry. I forgot to unmute myself. Sorry.
All right. Okay, you can start explaining.
Okay, so right off the bat, without doing anything, we can eliminate 3 answers.
Okay. What's 3?
The 3 answers are the I forgot A, E, and wait, how many answers are there again?
There's 5. So there's A, which is 10.5, B, which is 10, C, which is 11, D, which is 11.5, and E, which is 12.
Oh yeah, we can eliminate A, B, and E.
Why?
Because as you can see from the final result, if you look at it, DRA is equal to BAQ without subtracting R.
One sec. BRA?
Yeah.
BRA is equal to what?
BRA is equal to ARD.
ARB.
ARD.
Wait, you said that ARB, the area of ARB is equal to the area of ARD. Is
Okay,
that right?
No. ARD is equal to the area of ARB. No, I'm sorry. AQB. Yeah.
Okay, wait. So AR and D, this triangle's area is equal to AQB.
Yeah.
Okay. All right.
So then we know that the quadrilateral DRQC is about 1/3, and we know that AB is 5, AD is 8. 5 times 8 is 30. Is 40. If you divide 40 by 3, you get somewhere around 11 and 11 point. Oh, you get around 12 to 11. So then, yeah, we can eliminate 12, 10, and 10.5.
Wait, one sec, Franklin. So AB is 5, AD is 8, and ADR has an area of 16 because 8 times 4 divided by 2 is 16, and ABQ has an area of 25 divided by 2. because it's 5 times 5 and then divided by 2.
Oh yeah, basically.
Yeah, and then wait, can you please explain again?
No, I'm just going to get into the math. So basically, we know that BQ is 5, BC is 5, so we know that PQ is 3. And then, PQ is, wait, so, yeah.
Yeah, it's
5
2.
is 2.
Right?
And then if we make a square out of PRQ, and then we make a square out of it from cutting off portions of ABPR and ADR, and then we get a 2 by 2 square. Then 2 times 2 is 4, divided by 4 is 1. So we know that RPQ is 1. And then we already know that PC is, what's PC? Yikes.
PCD.
Yeah, we know that we know the area of PCD, so then we just subtract the area of PCD by 1, and then we get 11.5.
All right, so basically what you said is that we first found out the area of PCD, because if we were going to look at DCRQ, QR, then we can first do DCP, we find the area, and then we subtract the area of RPQ, the triangle, and then we get the shaded region. Right, so the answer is D. Great. So do you guys have any questions? All right, so now we can start working our way backwards, looking at the problems backwards. 23. There are various ways to make $270 with only $5 and $2. One such way is including this way, in how many different ways can 207 be made using only 2 and 5? So, so it gave us an example. So if we have 1 times 2 plus 41 times 5. Now, let's look at the properties. So this together will equal 207. So let's first say we have A2s plus B5s, and this equals 207. We see right away that if we want this to be true, B must be odd. Why is this? Because an even number, since 2A is always going to be even, plus an odd number is equal to an odd number. So since we saw this straight off the bat, it's going to be pretty easy. So all we need to do is we need to find out all the odd numbers for B. So for example, if we have B equals 1 and A would equal...
Yes.
What?
Oh,
Did you want to
I'm
say
sorry.
something?
No, I was just talking to my mom.
Oh, it's
Sorry.
okay. No problem. All right. So if B is 1, then A could be 101. 2 times 101 is 202, and 5 times 1 is 5. So 202 plus 5 equals 207. Now, so now we have that, we can see that if we use other odd numbers, then it's going to work as well. So if we use 3, then that means this is going to be 15 minus, that's 2, and then that's 9, 192 divided, this is 96 if this turns into a 3. See, 2 times 96 is equal to 192 plus 15 equals 207. Now, so for example, we have to prove that whenever B is an odd, it's always going to work. Well, for example, if we have let's say if 2A plus 5B equals 207, this works. So now we have to add, we have 2A plus 5. And then we have b plus 2 equals 207. And this a, let's just say it changed, so a minus n. All right, so how does this help? So this helps because I'm pretty sure it's what they call proving things by induction, which means that, for example, if let's just say an equation with n, if n squared is larger or equal to 0, then n plus 1 squared has to be larger or equal to 0. So if we can prove this, that means we can prove that for all n, they are larger or equal to 0. So that was just an example. So we're doing the same thing here. So if 2a plus 5b equals 207, then if we add 2 to b, and then we minus some number to a, then it's still going to work. Let's just say that. All right, so if we add 2 to b, we get 5b plus 10. And over here we get 2a minus 2n. So if we add this together, it equals 207. And then we know that 2a plus 5b equals 207. So we have 207 minus 2n plus 10 equals 207. And we can cross out the 207s on each side. We move the negative 2n to the other side. And 10 equals 2n. And then n equals 5. Which means that every time b increases by 2, a decreases by 5, and vice versa. So now we can actually start to calculate. All right, so we start calculating. So for example, if we have 1, 2, and how many 5s? 41 5s. Then that means our 5 could minus 2 each time. So then we get 39 5s, and then we get 6 2s, and so on. So let's look at the 5s line. So we have 41, 39, all the way to 1 5. And now we just need to count how many possibilities are there. So let's say we add each number in the list by 1, so we get 2 all the way to 42, skip counting by 2s. What that means is basically we're doing 2, 4, 6, 8, all the way to 42. And then if we divide by 2, we get 1, 2, 3, 4, all the way to 21. That means there are 21 numbers. 21 possibilities. Which means the answer is 21, that there are 21 different ways that we can make $207 using only $2 coins and $5 bills. So do you guys have any questions about how we just solved the problem?
No.
No.
All right. Okay. So we have question 21. In the diagram, ABCD is a square with side length 6, and WXYZ is a rectangle with ZY equals 10. Oops, then I marked it wrong. ZY is 10 and XY is 6. Also, AD and WX, so we have ABCD, ABCD. Also, AB and WX, AD and WX are perpendicular. Shaded area is equal to half of the area of WXYZ. The length of AP is. So first off, let's look at some angles. 90 degrees here, 90 degrees here, 90 degrees here, and 90 degrees here. We can do the same thing. This is 90 degrees, this is 90 degrees, and this is 90 degrees. Which means we see that this is actually a rectangle. So the side length of the square is 6. And then we know that 6 times some length n, it equals half of 10 times 6. That means n equals 5. See, this is the area in here is 30, and the area in the large rectangle is 60. And what is AP? This point is P. Well, the answer is 1, because the side length of a square is 6, and minus 5 equals 1. Is that clear? Number 20. Could anybody read number 20 for us? Lori took a 240 kilometers trip to Waterloo. 240 kilometers. On her way there, her average speed was 120 kilometers per hour. She was stopped for speeding. So on her way home, her average speed was 80 kilometers per hour. What was her average speed in kilometers per hour for the entire round trip? Okay, so we have 120 kilometers per hour while she was going there. So since there's 240 kilometers, then it took her 2 hours to get from her house to Waterloo. And from Waterloo back, it's 80 kilometers per hour. And if we multiply 3 to 80, we get 240 kilometers. We have to do the same thing to the denominator, so we get 3 hours. So it took Lori 3 hours to get from Waterloo to home. Alright, so now how we can find out the average speed is we can find the total distance, which was 480 kilometers, because remember, she went and she came back. Divided by the time it took, 5 hours, because 2 hours plus 3 hours, and this equals, so we have 5 times 9 is 45, and we have 30, and then 5 times 6, 6 is 30. So that means the average speed was 96 kilometers per hour. Alright, do you guys have any questions? No? Okay. Number 19. In the diagram, W, X, Y, and Z represent numbers in the intervals indicated. Which fraction represents the largest value? Alright, so first off, for the fractions, for example, we have A over B. The largest fraction we can get. See, the smaller B gets, the larger the fraction gets. For example, if we have like let's say 10 over 5, and then it's smaller than 10 over 2, which is smaller than 10 over 1, which is smaller than 10 over 0.5. And it keeps on going until you hit the negatives. And once you hit the negatives, for example, we have 10 over negative 1. This turns into negative 10. So yeah, it's still small, but like it's now a negative number. Right. So, and if the numerator, as the numerator gets larger, the fraction also gets larger. So, let me just erase this, and we can look at another example. For example, if we have 6 over 2, this is 3, which is smaller than 8 over 2, which is smaller than 10 over 2, and so on. So knowing this, we want the numerator to be as large as possible, which z is as large as possible, and the denominator as small as possible, and we don't want it to be negative. So we have w. So that means z divided by w is represents the largest value by using W, X, Y, and Z. Right. So do we have any questions?
No.
Okay. All right. So number 18. Does somebody want to explain this? All right. The number n is doubled and then has y added to it. So the number n is doubled and we add y to it. The result is then divided by 2 and has the original number n subtracted from it. The final result equals, okay, so well, we can put this on, we can like make this something over 2 so that we can do the subtraction. This equals 2n plus y divided by 2 minus 2n, because it's 2n over 2, which means 2n minus 2n is 0, and then we're left with y over 2. So there we go. Number 15. Sally picks 4 consecutive positive integers. She divides each integer by 4 and then adds the remainders together. The sum of the remainders are, well, if we have 4 numbers, let's say one of them has remainder 0. That means the next one has remainder 1, remainder 2, remainder 3, and no matter which one we start with, for example, if one of them, the starting one has remainder 1, it's remainder 2, remainder 3, and remainder 0 if we divide by 4. So 1 plus 2 plus 3 plus 0 equals 6. And that's the answer. And now, let's see, I think we explained all of these already. Oh yes. Number 12. In the diagram, AD equals DC equals DB. And BCA, so we have BCA equals 40 degrees. And what is the measure of BAC, so this angle? Well, we can see right off, since this is an isosceles triangle, this is also 40 degrees. Then we just have to find the other part. And this is 100 degrees, which means this side is 80 degrees. And since this is also an isosceles triangle, then we have the rest of the triangle is 100 degrees, and 100 degrees divided by 2 is 50. Each is 50 degrees, which means 50 degrees plus 40 degrees equals 90 degrees. All right, and at last, number 10. The number 519 is formed using the digits 5, 1, and 9. The 3 digits of this number are rearranged to form the largest possible and then the smallest possible 3-digit numbers. What is the difference between these largest and smallest numbers? Well, we put the largest digit first for the largest number. We have 9, and then second we have the second largest digit 5, and then 1. And then for the smallest number, it's vice versa. So we have 1, 5, 9. And if we subtract, we get 11 minus 9 is 2, 14 minus 5 is 9, and 8 minus 1 is 7. 792. All right, so now we're done doing all the questions. Just one sec. Here we go. Now we're done all the questions. There are a few more questions, but these aren't like these questions are not like boring questions. They're strange questions. Questions to make you very confused. Questions to make sure that you don't find the answer to the questions. All right. So have I showed you guys these questions before? Give me a yes or a no.
No.
No? Okay. All right. Then it was both times that I showed the grade 6 classes. All right. So first off, we have 5 apples. 5 apples are in a basket. How do you divide them among 5 girls so that each girl gets an apple, but 1 apple remains in the basket? Also, you guys should turn on your mics and like we can discuss about this question. So, Franklin, let me ask you, because you always have these really good ideas of how to get across these loopholes, and you have a lot of ideas with like ideas that get through loopholes a lot too. So, Franklin, do you have any idea of how to do question 7?
Buy another one.
Buy another one? Yeah. This is you in your casual voice. Buy another one? Okay. Yeah, but let's just say that there were only 5 apples and you're only allowed to share these 5 apples among the 5 girls.
Couldn't a girl just have an apple inside the basket?
Have you done this question before, Nathan?
No.
Oh, okay. Well, yeah. So we have 4 people with their apples and going normally, and apple 1, 2, 3, 4. And then we have another person that has their apple inside the basket. Yeah, okay. Great. That was like exactly that's like exactly the answer. All right, and number 8. Don't think too long. How many cats are in a small room if in each of the 4 corners a cat is sitting, and opposite each cat there sit 3 cats, and at each cat's tail a cat is sitting? How many cats are there? All right. Oops, my bad. Oops, I just clicked something random. No, get out of here. 1 sec, guys. All right, there we go. Okay. Okay, so first off, let's draw a small room. Yeah. And if in each of the 4 corners a cat is sitting, and opposite each cat there sit 3 cats, and at each cat's tail a cat is sitting. Ooh, so opposite to each cat there sit 3 cats.
Are there 3 cats in the room? I mean, are there 4 cats in the room?
Maybe. What makes you think so, though?
Because a cat can sit on its own tail.
Yeah.
And if a cat is sitting in one corner, then technically all other cats are opposite it.
Yeah, okay, yeah, well, okay, yeah. So that's exactly the answer. How are you guys like so good at guessing these things? Yeah, well, anyways.
Too many Looney Tunes when we were children.
Okay, well, so we have 4 cats, 1 cat at each corner, and like, see, this cat is opposite to 1, 2, 3, these 3 cats, and so on, and then the 4 cats put their tails in the middle. So yeah. Okay, well, you guys are very talented in this guessing game. So I've just one more for you guys. We probably won't have enough time to all like talk to do this one, but you guys can search it up like try it yourself at home or just search it up, whatever. I don't care. So this one is called Wolf, Goat, and Cabbage. A man has to take a wolf, a goat, and some cabbage across the river. His rowboat has enough room for the man plus either the wolf or the goat or the cabbage. If he takes the cabbage with him, the wolf will eat the goat. If it takes the wolf, the goat will eat the cabbage. Only when the man is present are the goat and the cabbage safe from their enemies. All the same, the man carries wolf, goat, and cabbage across the river. How?
I know how.
He carries the goat over first, and then he brings the cabbage over. And then he brings the wolf over after he comes back.
And then he takes the goat back, and he takes the cabbage again, and they go back for the goat.
Yeah. Okay. Yeah, all right. You guys are very fast, and like I feel like you guys have seen these questions before.
Only the wolf.
I've seen that one, except it wasn't the exact same 3 characters.
Okay, well, anyways, and then we also have another one, repairing a chain. Do you know why the young craftsman in the picture is so deep in thought? He has 5 short pieces of chain that must be joined to into a long chain. He opened uh, uh, 3, so this chain 3. So he opens chain 3 and links it onto chain 4, and then unfasten ring 6, which means open ring 6, get out on ring 7, etc. And this task would he would complete his task in 8 operations, but he wants to do it in 6. How does he do it? So you guys can think about this at home. Yeah, okay. Please don't spoil the answer, you guys, because yeah, you guys are gonna get it in like 1 second. So Franklin and Nathan. So yeah, all right. Well, anyways, that's it for today. Thank you all for coming, and I wish you guys a good week. You guys can leave now.